Today on How It's Made. Evaporative cooling towers. Evaporative cooling towers keep large buildings and industrial machines cool. Circulating liquid carries the excess heat to the cooling tower, typically installed on the roof. The tower uses cold water to cool that fluid, then transfers the heat to the atmosphere through an evaporation process. Pumps move the fluid carrying the excess heat through the cooling tower's closed-circuit coil. Nozzles spray the coil with cold water. The spray water absorbs the heat, and the cooled fluid returns to the building. Fans blow air onto the now warm spray water to evaporate just enough to release the heat. Then the cooled water loops back to the spray system and the cycle repeats. Depending on the size, the coil is made up of as many as 56 circuits. A circuit is a zigzag tube, 1 inch in diameter. The mill forms a continuous straight tube from a strip of carbon steel. The rollers progressively curve the edges upward until they join at the top. The last station on the mill welds the joined edges together to form a continuous seam. Next, workers transfer the straight tube to a semi-automated tube bender, which forms it into a circuit. Depending on the size of the circuit, there can be as few as 6 bends or as many as 18. To make a circuit with 18 bends can require a straight tube that's over 300 feet long. Once all the circuits are ready, workers stack them on a frame. Then weld the tube ends to the corresponding holes of a steel plate. They close up the plate with a cover called a header. After clamping the header in position, they weld it in place, forming a pressure-tight seal. The coil is now fully constructed and ready for testing. Technicians submerge it in water, then pump air through at high pressure and look for bubbles, which would indicate a leak in a circuit. If they do find a leak, they either repair or replace the circuit. Meanwhile, work is underway on the cooling tower's mechanical section. A computer-guided laser cutter prepares the steel panels that make up the section's rugged structure. Workers then bend the panels where required with a machine called a press brake. Then they assemble the panels to build the structure. Meanwhile, another team has assembled a mechanical section ceiling which houses the fans. Workers lower this onto the structure. Inside the mechanical section, they install the belt that links the motor's pulley to each fan pulley. After tightening the belt screw with an impact wrench, they test the fans. Meanwhile, the coil has been dipped in molten zinc to make it corrosion resistant. Workers mount it next to the cooling tower's mechanical section. They cover it with a steel housing and install the water spray system on top of it. The sprayed cold water absorbs the heat from the fluid circulating through the coil. The fans then cool the water by evaporation as it flows downward through a bundle of PVC sheets. The machine first heats the PVC to soften it, then stamps it with a mold plate. This imprints a proprietary pattern of peaks and valleys. This pattern is the secret to the evaporative cooling process because it moves the air and spreads the water in a way that maximizes efficiency. Workers stack the sheets on pole supports to construct a bundle of 300 sheets. After placing the bundle in a housing, they install it over a basin. This basin collects the cold water before it's pumped back up to the sprayers to repeat the cycle. This completes the cooling tower's lower module. They now mate it with the upper module, containing the fans, coil, and spray system. This evaporative cooling tower has more than 300 times the capacity of a typical residential air conditioning system. Now that's pretty cool.